Yeah. Hello, everyone. So we're MPCStats team at PSE. So today we'll introduce our project, and it's currently worked on by Jern and I and Kazumune. Yeah. So the goal of our project is to build a framework that allows users to query statistical computation across different data providers, while guarantee the data privacy and also the correctness of the result. We've implemented common statistical operations using MPSpeed, which is a well-known MPC framework. We've supported 12 statistical operations and also some common table join and array concatenation and filtering. So users can define computation like this. And we also integrated TLS notary so that the inputs to MPC are authenticated from some well-known websites so that we can prevent garbage in, garbage out situation.
All right, thank you, Kelvin. So basically, right now, we are talking about MPC, right? So intuitive approach for MPC is that having all parties, data providers, data consumers, to join as a computation parties, right? The bad things, the good thing first, let's say, is that it's free verifiability because everyone is in the same computation set, right? So they know what computation is done, right? I request mean, I know that this guy just compute mean for me, right? The bad thing is that the data providers, consumers, everyone need to be online at the same time. And it's really hard, right, for many numbers of data providers, especially when the number of data providers grows, the computations grow skyrockets so badly. So how to solve that, right? We use another approach called client interface, which basically means that the data providers and data consumers are not in the computation parties. So there's three phases. The first phase is that data providers secret share their data through some delivery links. They can log in, share data, and log out. And then another set of computation parties compute data, and once it's ready, data consumer just log in to get it out. So this is good because they are now the data provider and consumer doesn't need to be online at the same time, which makes sense. And it also doesn't grow with the number of data provider because the cost of the MPC computation is actually from the number of the parties in the computation parties. The bad thing is that the data providers and consumer now need to trust the parties, right? It depends on our setup. If it's malicious, we need to trust at least one of the party is right. And again, because we are not joining in the MPC computation party itself, we have no idea what is the function that they calculate is actually the one we want. But again, the trust assumption is the same, that if you trust that at least one for the malicious setting of the computation party is honest, we can be sure that they just run the computation that we want, like mean or median or anything we want. So use case, we are thinking about cross-department data sharing, government, verifiable salary data, any survey research for policy planning, and yeah, many more, let us know. So demo time. So this is currently up and running. We're still under maintenance, final optimization because it's pretty big, so we will notify soon, but it's pretty interesting to explore ETH balance inequality at Devcon. So what it means, you guys can use your Binance to share it privately. We won't know your Binance balance, but then we will be able to calculate the interesting stat we will show later. But you guys should join this group first. So we will notify by today or tomorrow once the Docker file is smaller so that it can make sense to run in this internet in Devcon. So the caveat, right, because we want to be upfront, so we will only allow you to share privately the free ETH in your spot balance of Binance. And again, the parties could still learn the number of digits, although this comes from the limitation of the TLS notary itself, that the parties still know the number of digits of your Binance balance, but again, we won't know actually the number. And again, this is the trust assumption that we trust that our three party doesn't collude, right? And yeah, please join this Telegram group. We will get updates soon, and anyone who joins will get a chance to win an NFT and win a lottery as an actual cash. So yeah, so this is just a quick go through. It will already be in our README, in our demo. So get Binance API key, just go, Binance API key, everyone know how to do that. Get the API key and secret key. Make sure it's read-only. And then, yes, so notarize this. This is only our script that you need to run. You just git clone and you run. And make sure that your Docker is opening and running on your laptop. And then, you just run this. Again, this is just one line, and each address is just address for receiving the price. This is not the address for the Binance. This is just to send the price if you want one. And yeah, this is the website. So we are having max ETH balance of Devcon, mean, median number, and Gini coefficient to make sure of the inequality. So yeah, join us. Thank you so much.
Thank you, Kevin, John. Any questions? Oh, that's too far. Okay, you got it.
Hey, great talk. It's not clear to me. Are you guys trying to collect like aggregate statistics from like multiple parties? And if that's the case, and that's the use case, did you explore something like a PRIO-like system? You know, using like function secret sharing? I don't think MP Speed support that, so I'm kind of curious. It should be much more efficient.
Yeah, thank you so much for suggestion. Yeah, I think we've looked at through some of it, but this limitation mostly is through the number of data providers. So right now, again, like FSG, multi-key, functional encryption, secret sharing. Yeah, we looked through some of them and we're thinking of using some, but again, the limitation right now is that the state-of-the-art MPC for a huge number of data providers, it still matters. And we think again, because we make sure, right, that we don't want the competition to just grow indefinitely with the number of data providers, so we still choose this. But thank you so much for
Yeah. So just look at function secret sharing. I think it would really boost your results.
Thank you. I appreciate function secret sharing. Note.
Do we have any other questions? Oh, there's one.
Hi, I was trying to scan the TG QR code that you showed just now, and it says link expired for me. Is it just t.me/MPCStats? That's the link?
Yes.
Okay.
Sorry about this.
So t.me/MPCStats.
Yeah.
Any other question? Can I ask a question? I know that the federated learning is similar to, you know, preserving privacy, and then the medical hospitals, they're having a lot of, you know, confidential data of the patients, so they use federated learning. I just wonder what you're presenting, how different it is from federated learning.
Yeah, so basically federated learning is like you trains offline, right? Like data is still there, and then you send the update on the gradient descent or anything to your machine learning up in the air, right? So basically you train everything update, but now MPC, it means that you gather data from different parties and compute at the same time. So for federated learning, so it can use, actually it depends on what types of thing you use, but it can also use MPC itself. So, but yeah, when it comes to federated learning, people still consider like not too many parties all at once. But when we're thinking about stats, we're thinking about like population. So we wish to make it more scalable in terms of like number of data providers itself. But yes, I think a lot of federated learning techniques still use MPC, but we just want to make sure that MPC framework that really scalable to a huge number of data providers. Yes.
Okay, thank you.